right. Hello, everyone. So yeah, I'm glad to be back at the Biohacker Summit. The last one was in 2020. It's been kind of hectic 2 years, but yeah, glad to be back here and share with you, I think, some of the more like trendy topics in biohacking and health right now, which is NAD. So many people might have heard about NAD in the context of like anti-aging and longevity, which I hope I'm going to just share what is NAD in my speech, and also how can you leverage that information, but more importantly, how can you essentially use this concept through natural means, not necessarily taking different kinds of supplements, as a lot of people may promote right now. And as like a brief introduction, I'll just use this quote by the 1930 Nobel laureate Hans von Euler-Chelpin, and he has said that NAD is one of the most widespread and biologically most important activators within the plant and animal world. So I guess I'd just like to talk about very important topics, or what is the most essential and fundamental processes inside the body that involves NAD. And a little bit about me as well. I'm Siim. I'm an author, written like 6 big books by now. And I'm a speaker, anthropologist by education, and a content creator as well. And this is I think my 7th Biohacker Summit since like 2017. I've been to all of them. And what is NAD then? The long name for NAD is nicotinamide adenine dinucleotide, which is a bit like a mouthful, but NAD is much easier to say. And NAD is essentially a coenzyme in the body and an energy regulator. Most of it has to do with energy production, but everything inside your body is linked to energy. Like without energy, you would die, and without NAD, you would also die. And NAD, as an enzyme, is involved with virtually every process inside the body. It regulates epigenetics, it turns on different kinds of longevity genes and cofactors. It's involved with DNA repair, genomic stability, helps with antioxidant defense, mitochondrial function, like exercise performance, brain performance, everything, sleep and wakefulness cycles as well. So it is kind of essential to the body as a whole. And low levels of NAD have been found to be linked to all of the hallmarks of aging, such as DNA damage, loss of proteostasis that Olli talked yesterday about, mitochondrial dysfunction, cell senescence, stem cell exhaustion, compromise autophagy, everything. Once you have low levels of NAD, you start to see the accumulation of all these hallmarks of aging that start to accelerate the biological aging process. So I wouldn't say that NAD is some sort of a magic pill that's going to make you live forever, as some people may claim right now on social media, but it is important in the way it regulates all these, let's say, epigenetic processes of biological aging, and at least slowing down some of them. We do also see that the levels of NAD drop a lot when you get older. You lose more than 50% of your NAD after the age of like 30 or 40, somewhere between there, compared to what you had in your youth. So that's why children generally they don't get these comorbidities like diabetes and metabolic syndrome that easily compared to older people. Whereas with older people, they're much more vulnerable to all these lifestyle diseases because various factors, but a lot of it may have to do also with NAD, because we also see that the elderly who have higher levels of NAD and higher levels of expressing NAD through different means, they also show or reduced of these age-related diseases. They have less diabetes and less comorbidities because they have higher NAD levels. We also see that boosting NAD with NAD supplements or precursors improves health span, so it reduces the expression of these comorbidities and like insulin resistance and diabetes, like taking NAD boosters, the main 2 ones being NMN or nicotinamide mononucleotide and NR, nicotinamide riboside. Using those precursors, they raise NAD levels in subjects, in humans, and they also improve metabolic health, and they have neuroprotective effects, mitochondrial protective effects, and just even weight loss can be seen by using that. But I wouldn't go about saying that, just take the pill, just take the NAD supplement, and you're gonna, basically live longer and be healthier. There are many, ways your body can produce NAD. The precursor supplements are just one of them. And your body can also make NAD from food, although to a much smaller degree. And it can also produce its NAD on a daily basis continually by recycling it. And this recycling pathway, or the salvage pathway, is, I think, the most overlooked aspect of increasing NAD, and it's also actually the biggest contributor to how much NAD you produce on a daily basis. So there isn't like an exact number or exact percentage that I've come across, but the physiology does suggest that up to like 80% or 90% of your daily NAD levels come from this salvage pathway that is being recycled. And that is kind of the main focus of my speech as well, of how can we improve the salvage pathway, because once your body's salvage pathway of producing NAD goes down or goes offline, then you're kind of losing out on a lot of the potential of making NAD on a daily basis. And kind of the key to slowing down aging and living longer is producing energy all the time, having this like higher expression of epigenetic information that is associated with longevity, compared to not producing the NAD and seeing this acceleration of these hallmarks of aging. So how does the salvage pathway work? So this is a bit of a complex slide. I'll explain it. Yeah, this is the way your body produces NAD through different pathways. And there are 3 pathways. Number 1 is the price handler pathway on the top left. You get nicotinic acid from food, and that gets converted into basically NAD eventually. Nicotinic acid is a form of vitamin B3, or niacin is also here categorized, and that's kind of quite of a relatively small amount of NAD that you produce. The second pathway is the de novo biosynthesis pathway, and this one also comes from food. So tryptophan, which is an amino acid, that also gets converted into NAD eventually. These 2 are the food pathways, and the last one that contributes the vast majority of your daily NAD is the salvage pathway, or the kind of recycling pathway. And the recycling pathway works through the NAD consuming enzymes. So there are different things in your body that consume NAD. Most of the NAD that you have is being used all the time through counteract different environmental, let's say, processes, or you get exposed to UV radiation or some sort of oxidative stress or inflammation, and your body uses NAD to counteract that, to repair the damage. So like you get exposed to sunlight too much, you get burnt, or if you have high levels of NAD, then you don't get burned. But there are different kinds of, every day you get exposed to stressors and things that consume your NAD. And these things involve sirtuins, which are circadian rhythm related proteins, PARPs, which are DNA repair proteins, and CD38, which is a glycoprotein that is associated with inflammation. So basically damage, inflammation, and oxidative stress consume NAD. This then converted into nicotinamide, which is NAM. That's also like a form of niacin that you could get from as a supplement or from food. And nicotinamide is actually quite like a cheap version of all these NAD precursors. It's very cheap. It does go directly into the salvage pathway, and it's a good alternative to like these other NMN and nicotinamide riboside as well. Nicotinamide, NAM, gets converted into NAMPT, which stands for nicotinamide phosphoribosyl transferase. So that's also a mouthful. So NAMPT is kind of the bottleneck in the salvage pathway. So it's a very critical enzyme inside the salvage pathway that determines how much NAD gets through. So it's the rate-limiting step that you need to have. Like you can have all the other things in place, but if you don't have the NAMPT enzyme working properly and online, then you're not going to be recycling the NAD. And that is kind of, I think, one of the main things that I haven't seen anyone else really talk about, even like all these top longevity doctors. They do promote the idea of using NAD and NAD precursors, but I haven't never seen like talking about this specific enzyme, NAMPT, which is, it's literally the bottleneck that determines how much NAD you're going to have. NAMPT then gets converted into NMN, nicotinamide mononucleotide, and that eventually gets converted to NAD. And whenever you do produce NAD, some of it is also going to back to the recycling pathway. So yeah, you could take the precursors and bistep the NAMPT enzyme, like you can take nicotinamide riboside or NMN as a supplement, and you could get an elevation in NAD. You see a rise in NAD levels, but it all goes back to the recycling pathway. And if the recycling pathway isn't working properly, then you're just boosting your NAD levels, and then you're losing out. You're not going to be recycling it, so it's kind of a waste. Like your body is very efficient and very good at having all these processes working continuously and not wasting anything. So you don't want to kind of waste anything as a organism. So that's why the salvage pathway, in my opinion, is kind of the most important thing when you want to have NAD levels high and to slow down aging by doing that, by having that level elevated. And this is another key idea that I want to share with you, and that relates to the title of a speech, which is circadian NAD. And NAMPT, the critical enzyme in the salvage pathway, is determined or it's dependent of the circadian rhythms through sirtuins. Sirt1 is the main circadian rhythm protein that determines whether or not NAMPT is turned on or off. So what you have is this very complex system that you have the circadian rhythms aligned and working properly that elevates Sirt1, and that also allows NAMPT to start recycling the NAD. If you don't have the circadian rhythms aligned, then yeah, you're just not going to be having this salvage pathway working properly. So what is circadian rhythms? I'll give a brief overview about those things as well. Circadian rhythms are these very fundamental diurnal cycles inside the body. They're linked to the day and night cycles of the environment. And these clocks, these circadian clocks, they regulate basically every other process inside the body. There's a clock, the master clock inside the brain called the suprachiasmatic nucleus. And there's also a circadian clock in every organ in your body, the heart, the liver, the pancreas, and every cell also has its own circadian clock. And these clocks then control digestion, your hormones, mood, energy production, insulin sensitivity, sleep-wakefulness cycles, cognition, etc. Everything is related to that. And the circadian rhythms are regulated by different cues. And the main ones are feeding or food intake or not. Fasting can also be contributed there. And light, which is light waves going through your eyes into the brain, stimulating the master clocks and then affecting all these processes. There's also movement, physical movement, temperature as well, cold, warm. All those things are signals to the body of it's daytime or it's nighttime, and this is where you should do certain things. For example, this is where you should sleep. There are different hormones and processes that are allocated to the period of sleep, and there are different processes allocated to wakefulness. So if you're, as an organism, you want to, repair yourself when you're sleeping and be active and be very metabolically active during daytime when you're moving. And all these light, feeding, movement, temperature cues, they regulate these processes so that everything would work like clockwork, pun intended almost, that these clocks are very kind of fundamental. Disruption in the circadian rhythms are linked to many diseases. Even the World Health Organization categorizes shift work, which is kind of a classic circadian disruption, that is categorized as a carcinogen. And what you see is that circadian disruption, misalignment with the circadian rhythms, or just deterioration of the circadian rhythms is increasing biological aging. It turns on all these aging pathways, it increases inflammation, promotes heart disease, metabolic syndrome, diabetes, weight gain, it causes DNA damage, damages the mitochondria, neurodegeneration, Alzheimer's, all those things go up with circadian disruption. And it also turns off the beneficial longevity pathways, like it turns off the sirtuins, it turns off NAD recycling, it turns off autophagy, it turns off DNA repair, yeah, I mean, that's just a recipe for disaster and accelerated aging. And being aligned with the circadian rhythms does the opposite. When you're aligned with the circadian rhythms, you see an increase in the longevity pathways, or everything is working as it's supposed to. The NAD recycling is working as it's supposed to, autophagy, DNA repair, and everything is going as evolution had it planned for our organism. A brief overview, let's say like an interlude before we carry on. So, circadian alignment is kind of the key to having high levels of NAD, and in so doing, slowing down biological aging and having increased health span. Health span being things related to just your metabolic health and functional fitness and being youthful for long, not necessarily like living longer. But it's still quite, for quality of life, it's very important. So for that, you need CERT1 that is related to circadian rhythm alignment. CERT1 goes online, that then turns on the NAMPT enzyme. NAMPT starts to recycle NAD on a daily basis, and with high levels of NAD, you see an elevation in the longevity epigenetics and a down-regulation of the hallmarks of aging. And as a result, you have this increased health span. You're like functionally fit and healthy for longer. On the opposite, you have circadian disruption. When that happens, like you have a bad night's sleep, or you're jet lagged, you're in a different time zone, you're staying up late, or you have irregular sleeping patterns, all those things, then CERT1 tends to go offline, or it decreases, and that also shuts down the NAMPT enzyme, which then turns off NAD recycling as well. You're not going to be recycling that NAD anymore until it turns on again, and as a result, you see a down-regulation on the longevity epigenetics and an increase in the hallmarks of aging. You see higher inflammation levels, higher blood sugar levels, some aspects of insulin resistance, and etc. And you get accelerated aging, biological aging from that. Obviously, it's like a dose-specific response. Like having one bad night's sleep isn't gonna kill you, and it's not gonna give you diabetes either. You may, over the course of weeks, months, and years, that's where you start to see this accumulation of the damage. Like none of these things happen overnight, and you're not going to get well overnight, and you're not going to get sick overnight either. But let's say as a chronic lifestyle, let's say orientation, if you're more towards the circadian disruption as a lifestyle, then over the course of time, you will see accelerated aging because of this down-regulation of NAD that regulates all these longevity epigenetics. Okay, let's carry on. The main circadian rhythm that actually determines or controls the circadian alignment is the cortisol melatonin diurnal rhythm. So it's very simple and it's very basic. Us humans were diurnal creatures, we're not nocturnal, we're not owls. We're supposed to be active and awake during daytime, and we're supposed to sleep at night. That's how we've been as a species for how long, who knows. And the cortisol melatonin rhythm works like this, that in the morning you start to produce cortisol around dawn, like 6 a.m., 5 a.m., it starts to rise a little bit to wake you up. Cortisol is considered the stress hormone, and people think that it's bad. I mean, excess cortisol can definitely be bad, linked to stress-related diseases, but as a hormone, it's kind of neutral. The purpose of cortisol is to just give you energy and wake you up. And in the morning, it is very important to have this rise in cortisol to kickstart the day, essentially, and give you this energy to start. Cortisol peaks at 9 a.m., and then it starts to decline. It drops down all throughout the day and stays low all throughout the night. In the evening, you start to produce melatonin instead. Melatonin, considered the sleep hormone, and melatonin's job is to make you sleepy, make you fall asleep, make it easier to stay asleep, and also has many other longevity processes. Like I personally think that melatonin is kind of the most important longevity and anti-aging hormone. So sleep is, essential for health, but melatonin as a hormone itself regulates all these beneficial processes that happen during sleep. So melatonin regulates all the antioxidant defenses. It regulates autophagy, apoptosis, brain detoxification, bone health, growth hormone, the immune system, inflammation, even memories, fat burning. All those things are working together with melatonin. So almost like you're active during the daytime, you're expending energy, you're causing yourself physical damage and oxidative stress by being alive, and at night melatonin comes and kind of processes all that and starts to repair. And all these things work together, like autophagy and apoptosis work together with melatonin and growth hormone as well, so that your body doesn't want to waste anything. It wants to make sure that it repairs itself when it's the safest to do so and when it's the best time, when you have high levels of melatonin. So now for the rest of my speech, I'm going to give you a few key ideas for maintaining or say creating this optimal circadian NAD cycle or principles that to follow. And the number one principle for that is get exposed to morning light, bright light exposure in the morning after waking up. And this is going to start the circadian rhythm. It's going to tell your brain that it's day or it's morning and you should wake up and start these processes. It raises cortisol, it improves your mood, it gives you energy, it starts the metabolism, etc. But it also actually helps you to produce melatonin at night. So this morning light is kind of starting this program that tells, okay, you need to actually start producing melatonin as well at nighttime by stimulating these different genes in the brain. And I mean, obviously we're in Finland. Today there wasn't any sunlight in the morning. Yesterday it was, but it doesn't matter because you still need to get exposed to some sort of bright light. Any kind of bright light can do the trick. Obviously these kind of lights or your smartphone isn't ideal, but it's still something that does start the circadian rhythm. And there's different kinds of face lamps, bright face lamps. Those are good alternative. The best obviously is the sunlight, but you can't always get access to that. Regardless, if you go outside and it's cloudy, then the outside brightness is still like maybe 100 times brighter than indoor light. So even if it's cloudy, you can go outside and you still get some of the beneficial effects. And it does, give you the same signal or the same important cycle. Number two is block blue light at night, or artificial light more specifically. And the reason for that is that this blue as well as green light, it suppresses melatonin a lot. It suppresses nearly like 90% or 98% of melatonin if you get exposed to these kinds of bright blue lights. And green light is also there. So anything between like 550 to 400 nanometers is the most melatonin suppressive wavelength of light. And what it does is just tells your brain that it's actually daytime. Naturally, you would get exposed to blue light and green light in the morning or the daytime, but in the evening you would get exposed to mostly orange, amber, red, yellow, this kind of lights that resemble sunlight or bonfires or candlelight, etc. Like this, artificial lights are relatively new in the development of a species, like only like a few hundred years old, and yeah, naturally we would never get exposed to these kinds of bright lights in our environment. This is an overview about what does, approximately what does the wavelengths of light naturally look like. So in the morning and noon, afternoon time, you get quite a balanced spectrum of all the different wavelengths. You get some blue, turquoise, green, yellow, red, etc. in a balanced way. So that's the natural sunlight. It's kind of healthy spectrum of light. In the evening, the blue light decreases, and you get more red, more amber, so it resembles sunset. And at night, the only light you would ever get exposed to would be red, essentially, and orange, usually from sunsets and candlelight. So essentially, it just causes circadian mismatch if you get exposed to a lot of blue light and green light before bed or at nighttime. So it just suppresses melatonin, which then makes you produce less melatonin at night and prevents you from producing NAD, as well as having all these other longevity processes working together when you're sleeping. This is another overview about this circadian cycle from a light side. Actually, it's, a lot of people may think that you need to get exposed to like a ton of bright light immediately after waking up, which actually isn't the case. The brightest light you get exposed to around noon, when the sun is at its zenith. And in the morning, you do get like bright light. It's very intense, but it's not super like bright as you would during the daytime. So in the morning, you would want to get like bright light, not super intense. And at noon, you would get exposed to this very bright light And as the day progresses, in the evening, the light should start to dim down, more like yellow, orange, and eventually red in the evening. And there are different, light bulbs you can use in your house for that. There's also like blue blocking glasses that you could use that are very popular. And yeah, you can definitely like hack it or biohack it, because obviously most people aren't willing, they're not willing to turn off their smartphone completely, so they still use it quite late in the evening or watch TV, etc. But there are like healthy alternatives or making it much healthier by using these filtering and biohacking technologies. Melatonin, like I said, I think it's one of the most powerful anti-aging hormones, and melatonin has, let's say, aging cycle as well. You produce quite a lot of melatonin when you're young, as a child, for different reasons. It peaks in your early childhood, and melatonin production starts to decrease around puberty. When you hit puberty, your melatonin production goes down. And actually, this drop in melatonin is what offsets puberty. They've seen that if you give like melatonin supplements to children, then they have some prolonged, or they postpone their puberty a little bit. So I wouldn't like recommend taking a melatonin supplement for children or teenagers for sure, because it can like downregulate some of these changes that happen during puberty. But after puberty, when you're in adulthood, you naturally start to produce a lot less melatonin. This decline in melatonin continues until your elderly years, and you produce very little melatonin in your, let's say, 60s and 70s, which, in my opinion, is also quite bad from a longevity and anti-aging perspective. And this melatonin drop isn't the only thing that happens. Like all the other circadian hormones also decrease with age. Like cortisol production drops, and just the overall circadian suprachiasmatic nucleus firing and all these longevity circadian clocks, they just stop working, or they dampen, they flatten. There's less of these big ups and downs in the circadian hormones. The healthy thing that you have when you're young and in your adulthood is to have this big rise in cortisol in the morning, drop it down and produce a lot of melatonin at night and drop it down, etc. So this amplitude is very beneficial, like almost HRV, like huge ups and downs in this amplitude is what is beneficial for the longevity. And once you start to see this decrease that happens with age, is when you start to also see the other diseases take place. Like you have less antioxidant defense and less NAD from that, which then makes it easier for you to develop diabetes and gain weight and develop Alzheimer's. But fortunately, it's been found that you can actually prevent this. You can prevent this dampening. You can maintain this higher amplitude even in your elderly years. And the key for that is, again, NAD. So it's actually kind of very interlinked with each other. So to have this higher expression of circadian clock hormones, you need NAD, and these big amplitudes of these circadian clock hormones and the circadian rhythm alignment, etc., produces NAD as well. So it's I don't know, like a chicken and egg situation or something that, which one is which, but the key is that if you have high levels of NAD, then you can maintain health span for longer, because you produce more melatonin at night, you produce more cortisol in the morning, etc. And different things that actually help to maintain high levels of NAD and maintain the robustness of the circadian clocks are different activities that are listed on the left, like calorie restriction, intermittent fasting, being aligned with the circadian rhythms, and exercise. Those things boost NAD levels naturally, and they also maintain the circadian clocks, and they can rewire. Like even if you have already experienced low levels of NAD and you've experienced circadian disruption, you've experienced this downregulation of melatonin, you can still turn it back. You can literally turn back the clock by boosting your NAD levels. I mean, obviously, one way of doing that is with NAD supplements, and they have used NAD precursors like NMN and NR to do that. They have used these supplements to reverse the clock, but like I said, there are also maybe like natural ways, more like sustainable ways, more, let's say, more freer ways to do that, to not be dependent of like a supplement all the time. And things that derail these clocks, destroy these clocks, speed up the process of aging and speed up the deterioration of these clocks are all these circadian misalignment things, like shift work, jet lag, traveling, circadian disruption, chronic inflammation, and obesity, which is a state of like chronic inflammation and DNA damage. All these like just lifestyle diseases, diabetes, any kinds of these, maybe probably like nuclear radiation, all those things, just damage. The more damage you experience, the more of these clocks will start to destroy or be destroyed as well. Point number 3 is also to sleep enough, because all these repair and rejuvenation, recycling, all these processes happen when you're sleeping. Mostly in deep sleep, but also REM sleep is important. And usually the recommended hours for sleep are like 6 to 8 hours for adults. If you sleep less than 6 hours, then you see about like a 15% increase in all-cause mortality. If you sleep longer than that, that's fine. But at least they find that if you need to sleep like 10 hours or 12 hours, then there's something wrong with you. Or at least like they see that the reason why people usually sleep like 12 hours is because they are already sick and they just need to do that, and they see also increase in mortality. But it's not that the sleeping longer is bad, it's just that when you need to sleep that long, then it's a sign that something is wrong. But 6 to 8 hours is a good amount. That should be enough. But then obviously the quality of the sleep is very important as well. The more melatonin you produce at night, the better your circadian rhythm alignment, the more robust your sleep-wakefulness cycles and your sleep cycles are, then the healthier that sleep is going to be and the higher quality it is. So theoretically, you could also get away with just sleeping 6 hours. And it also depends on like how much damage you experience. If you do a lot of exercise, then that increases your sleep demand. If you're under a lot of inflammation, that increases your sleep demand, etc. But like sunlight exposure can also be a huge determinant of how much sleep you're going to get. So you get exposed to a lot of sunlight during the daytime, and you produce more melatonin at night because of that as well. Inflammation, I've talked about that, that's a bonus now. So inflammation causes aging, which is a term called inflammaging. And what it does is that increases CD38, which is one of the main consumers of NAD. And they do see actually in studies like a parallel correlation of when you see an increase in CD38, then the NAD levels also go down in like parallel. The more CD38 you produce, the less NAD you have, because the CD38 is consuming NAD, and your NAD is being used to treat that inflammation. And there are also like different kinds of CD38 inhibitor supplements, like apigenetic, quercetin, fisetin. Those things, they suppress CD38, and they actually raise NAD because of that. Inflammation also suppresses NAMPT, the rate-limiting enzyme in the Salvage pathway, reduces NMN, and you have less NAD because of that, which then, again, promotes hallmarks of aging and senescence. Reactive oxygen species, or just oxidative stress, that also causes DNA damage, and that raises PARPs, which are DNA damage repair proteins, and that also reduces NAD. So you don't want to be exposed to chronic inflammation, and that chronic inflammation mostly comes from lifestyle, like not sleeping enough, different kinds of toxins, bad diet, not exercising, those things. So there is still some inflammation is good, like from exercise, and some inflammation from let's say different compounds or supplements can be good, but chronic inflammation over the course of weeks and months and years that you see in this Western lifestyle mostly. So what promotes NAD recycling? Number 1, circadian alignment, being aligned with the day and night cycles. There are some differences, like some people are more morning larks, others are night owls, but regardless, no human is nocturnal. There isn't that we literally never get exposed to sunlight or something. So we do have this diurnal rhythm as a species, that we should get some morning sunlight and daylight exposure, etc., and sleep at night in darkness, preferably. Number 2 is exercise. So exercise also increases NAMPT enzyme, and they see that the elderly who exercise, they have higher expression of NAMPT in their muscles. So yeah, exercise is one of the most underrated as well. Anti-aging, it's not a drug, but it's more powerful than any drug we know. So you definitely should exercise all throughout your life in some different shape or form. And lastly, time-restricted eating, that is also promoting NAMPT. And time-restricted eating as a concept is coming from circadian rhythms, or the research about chronobiology as well. Calorie restriction can be categorized here. Time-restricted eating is a form of like restricting your calories, although with like a time interval, but still, it's intermittent fasting is what it's called, more colloquially. So, conclusion, how do you essentially turn on these longevity and anti-aging pathways? It's quite simple when you think about it. Circadian alignment, I think it's very important, one of the most underrated and best ways of maintaining high levels of NAD all throughout your life. Bright light exposure at morning to get this circadian kickstart, and block blue light at night. You shouldn't have like your phone next to your pillow and check the clock or whatever with the blue light coming to your eyes. You're just going to decrease your sleep quality and suppress melatonin. And you can use different filters. You can use blue blocking glasses to achieve that. And you can use red light bulbs, non-flicker red light bulbs. That's good. Regular exercise, quite important. From an exercise standpoint, then the cardiovascular exercise appears to be more beneficial for NAD because it increases NAMPT more. And like resistance training, if it's like maximum training, even like HIIT cardio, which is very popular, like literally grinding yourself through the dirt and pushing yourself all the time, that actually decreases NAD. So you don't want to be like, destroying yourself with exercise, but you do want to have like this aerobic fitness and good cardiovascular health and all things related. Time-restricted eating or intermittent fasting, I think there's different windows for that. You can do 1 meal a day, you can do 2 meals a day, 3 meals a day. But I think the main idea is to maybe not eat at night, eat when it's dark, or not eat when it's dark. Humans aren't supposed to do that. We're much more insulin sensitive during daytime, and at night we actually become insulin resistant. So as a species, we're also supposed to eat when the light is out and not eat when it's dark. And lastly, avoid inflammation, which is it's going to prevent you from losing NAD. If you have high inflammation all the time, then you're just going to leak, and you're using that NAD to deal with the inflammation. And I'm going to also use a concluding quote by Mahatma Gandhi: "Each night when I go to sleep, I die, and the next morning when I wake up, I am reborn." So that essentially describes this NAD cycling and NAD recycling, the circadian NAD rhythm, and everything related to that. So thanks for listening, and you can find all my contact information from there, and Siim also on all the social media platforms.